Hello, everyone. Welcome to SCITT IETF 123. If you weren't planning on being in SCITT, scan the barcode and stay anyway. We're going to get started. We've been asked to see if we can bash the agenda and have a few minutes at the end for a VCons use case. So if I can manage to do that, we will. John, you want to say hi? I don't know what time. Oh, you're pretty much same time zone, right?
Yeah, I'm just an hour behind you guys, so not bad this time.
Great.
Yeah, hi everybody. I won't take up any more time if we need another presentation in this packed agenda.
Well, we're going to see what we can do, right? All right, so let's go ahead and plow on. Note well, if you agreed to this when you agreed to participate in IETF, please read it, be familiar with it. This is the rules by which we participate. I'll give you a moment to read it. You will see this. It's still kind of relatively early on Monday. All right. Ask your friendly chairs or ADs if you have questions about this, who will probably point you to the LLC attorneys. Note really well, be nice to everyone. We do have an ombudsman if you have issues. If you have any kind of problems with interactions, the chairs will regulate the kind of conduct in the room if it comes to that. But otherwise, be nice. Meeting tips. If you're not logged on to the on-site tool, please log on to the on-site tool. We'll use that to manage the question queue. Remote participants like our co-chair, happily using this to participate as well. Handy resources. You'll see this as we go through the week for everybody who uses the template. All right, I'm going to pass off to John. Agenda. This is kind of what we're doing. We're going to see if we can steal 5 minutes in here, though.
Yep, thanks very much. So agenda is full. We'll do the usual status and architecture updates. Obviously, as most of you will know, we're very close on the architecture, and we've made a lot of progress on Scrappy too. So with the proof of the hackathon report and demo from Nicole, I think you'll see we've, as a group, got very far. So that's the first three things. Then we've got a couple of potential what nexts. So building on stuff from last IETF, we've actually got an idea now for the use case extensions, and then an alignment with Rescale, which is bill of materials use case. So again, very much in our wheelhouse, but just improving the detail and global reach of the SCITT standards with other people's standards. So yeah, it's simple agenda, and yeah, hopefully if we can get time, VCons also is an excellent use case and one that we've covered in previous IETFs, so it'll be good to update that too.
All right.
So if everybody's ready, I guess we can move on to Hank.
Thank you. Oh, this is unfortunate. Hi, this is Hank. This is my title slide. So this, I'm giving you a small recap and introduction to the architecture. And this is a revolutionary presentation. We will not refer to figure 1 for the first time, because we are pretty much where we want to be. Next slide. Oh, I'm doing the next slide. Yeah. So there are 2 documents in the data tracker as adopted. So one of them is the architecture. The architecture is not only an informational document, it is a standard spec document, because there are 2 items in there: how to sign your statement, which can be any opaque things. The go-to example is cat videos, but we are in the software supply chain use case, so probably it's more likely an SBOM or something like that. So that's covered in the architecture. We also tell you how to use COSI output, which is the COSI receipts. COSI receipts define certain types of verifiable data structures to give you proofs about the registry, the append-only log that you're using in SCITT. On the other side, you see another document that is a reference API for the supply chain SCITT stuff, and it's pretty far ahead. So there's status, The architecture is in AD evaluation. Deb gracefully so agreed to review the document. That's also followed. I think that's the next step. And from there we go to the IETF publication process, ISU ballot, and so on. The other one exists at the moment. And we were, I think the term is called fertling. I had to ChatGPT that term. So it's not really sneakily. I think ChatGPT tells me you're doing this under the covers. So now we are like cleaning up last parts. So you can see in this example that we forgot some TBDs that are now assigned due to the COSI registration and the VDS. So this is all updated. We have edited some media type for both messages, which is the sign statement and the receipt, for example. And then we got during the process a lot of PRs done. Most importantly, in order to expedite the process a little bit, and that might have been fertling, we removed the dependency to the reference API in the architecture, while at the same time strengthening the dependency of the reference API to the architecture. This is to not make the architecture document wait in a cluster in the RFC yet for the Scrappy, because it would have a normative requirement. So that we fertiled out. Again, a term that I learned. I'm using it a lot now. We added the media types that were pretty uncontroversial. They have been reviewed on the media type list. Then we made some updates to the security considerations, which in this part of the process is typical. It's way better now, and I think addressed all the comments. I think there's no pushback on that. And then some readability realignment, which is just shuffling words around. There's no content change. It's just better readability. And this is just highlighted PRs. Two were rejected because they were either too bothersome or we didn't like them. No, I'm kidding. No, they were not applicable anymore and outdated. So that's the actual reason. So that's where we are. And you can see it's scrappy. I also had some fertling. Again, this is very transparent. You can see it on GitHub, especially this is all examples. Actually, that's two PRs that were basically all examples using the DDN, right folding, making the RFC editor's life a little bit easier in order for net to them come back to us like, how do your lines look like, right? So there are some automated tooling for that. We are using that now, the folding for the examples, and we are actually adhering to the new EDN rules for the examples, which makes developers' life actually really easier. You can just copy out the example and use it in your code because that is now workable. So this is the update on the document stuff, and I've been trying to save in 5 minutes, and I think I succeeded.
Great, cool.
Any questions? Thank you.
All right, awesome. I'm Nicole Bates. I work in Microsoft's Azure Office CTO, and I will be kind of giving an overview of what many of us did this weekend at the hackathon. Many of us contributed our efforts towards two projects, the first being towards adhesives for supply chain security by Aoki. The group's goal was to clarify the challenges that cannot be addressed by the current specifications supported by the SCITT working group. After a few days, the group improved the problem statement logic, summarized key points for discussion, and clarified the positioning with related specifications. The second project was to demonstrate the interoperability of SCITT's transparency services. So I want to walk through that. Our goal for the demo was to produce receipts from multiple independent transparency services for the same signed statement, then verify those receipts and signed statement, and also add a third-party verification onto this. We also want to demonstrate an end-to-end workflow for supply chain security. So how do we do this? We took an artifact. Now this can be neutral. You can take an SBOM, you can take a firmware deployment. In our case, we took Microsoft's AI model, so the 5.4 reasoning model. And the first step we had to do was to create a statement. So take a claim. We created an in toto statement. This is a JSON formatted statement. It's widely used with SigStore. We created a manifest.json file. We then took this statement and we submitted it to our internal Microsoft signing services. We wrapped it in a cozy sign one envelope. We then took this signed statement and we submitted it to Microsoft's cloud transparency service. This is a SCITT implementation of the transparency service. We generated the first receipt. We then went ahead and took the same signed statement and resubmitted to Data Trails SCITT implementation and produced a second receipt. At this stage in the hackathon, we verified the signature on the signed statement, we verified the receipts, and we had a third-party verification that this was all correct and worked. We then pushed all of these artifacts, the transparent statement, into an Azure Container Registry. This is an OCI registry, OCI Container Registry. And that was kind of the end-to-end flow. With that said, I'm going to pass it over to Omri, who's going to go into details of the transparent statement and the receipts.
So there's a little script that's included in the repo called print cozy that you can use to sort of like print the details of the transparent statement. You probably recognize tag 18 at the top, which means that this is a cozy document. The protected header has a Microsoft issuer and a subject that we've set for this example, so that we've got experimental Microsoft by for reasoning here. So you recognize the standard sort of cozy envelope from Microsoft issuer about this particular model. You can look at more detail by running the script in the repo. And so then let's go into the unprotected header where the receipts are. So can we go to the next slide, please? So there's the first receipt there. 394 is the header parameter where the receipts are exposed in transparent statements. That's where they're embedded. This one's generated with the CTF profile for receipts. So that's using the Microsoft implementation. This is showing an inclusion proof. The key here in this case is accessible via the Scrappy API. It's not embedded in the receipts. So you get the various steps of the proof. You have to go and fetch the key from the service, and then you can verify the proof over the signature. You notice that there's a none there, which means that this is a detached payload. So you're reconstructing the payload you're verifying from the proof, and then finally verifying the signature. That's how receipt verification works. So if you go to the next slide now, please. Then we're showing the second receipts. That's using the MMR profiles. That's 3953. That's the data trails implementation receipts. Also an inclusion proof. Here, the cozy key is inside the receipt directly. It doesn't need to be fetched externally, and so you'll need to have some kind of pinning or root of trust reference to know that this is a valid key for the receipt. So finally, in the payload, we have the digest, the model manifest, because you're using cozy hash envelope here, and the signature for the statement at the end. So that's sort of, that's a quick look at the transparent statement in a nutshell. So if you can go to the next slide now, thank you. Then there's a little script called verify, which calls the two algorithms for verification. We're passing here the 2TS statement.skit, which is the transparent statement we've looked at just now. For the first receipt it finds, it goes to the issuer to fetch the keys, and verifies the receipt. For the second issuer, the keys embedded, and so we just verify directly. And essentially, this is verifying both proofs. This is very easy to try. It's on GitHub. You can create a code space. So you just click a button, it'll drop you in terminal, and then you can run the script for yourself or start playing with it and experiment with it. So just try to make it as easy to use and to pick up as possible. And then this is the third-party implementation of this. So Brian Zundel from Trade Verified did a TypeScript implementation of the same ideas. So it's verifying the statement here, and I believe on the next slide it's verifying the receipts. Yep, thank you. So verifying the CCF receipt and the MMR receipt, checking the proofs on both, getting the keys. And so we have two separate implementations of this, checking receipts from also two separate implementations of the transparency service. And I think that's a demo in a nutshell.
Yeah, thank you. So I think we can pause and take some questions here before moving on to Scrappy. Are there any questions?
No one in queue.
Actually, there was one more I forgot. This is actually the most important part, is where you're going to store all these artifacts. So I'll make this as the last slide.
Yeah, sorry. I forgot about that. So we want to make these artifacts available and easy to access for everyone. And the way to do that is to use ORAS to push them to an OCI compliant repo. So this is ACR in this case. So we're pushing the model manifest first, and then we're pushing the transparent statement as supporting evidence. And so users who discover the model manifest can also get the supporting evidence, the transparent statement easily, and they can use it to establish the provenance and the transparency of the model manifest they're looking at. So these are all like very standard comments, and this is kind of a standard way to go and push and retrieve information from an OCI registry, which is widely for containers and other types of artifacts. So this is a way we propose to disseminate this information.
So in the first slide, we included a link to the GitHub repo. It's reproducible, and so I encourage everyone to go and download these things and try them out for yourself. And with that, we'll move to Scrappy and what's next.
Yep. So I think Hank summarized the changes earlier. Actually, it's mostly been editorial changes since last time, alignments with related drafts, fixed a bit of terminology, improved the samples, some tidy up. So there's links to PRs there, but nothing too substantial to review. So there's just one item that I would like to get into quickly here. If you can get to the next slide. So right now, the API surface is very consistently CBOR cozy. We use constraint problem details for errors even. And we have a well-known transparency configuration, which is CBOR2, where you can go and discover the configuration for the service. But it's not very specified at the moment. We only have an informative example, and that uses OAuth style key discovery, which is fine. Like that's well understood, and there are implementations of that. But it kind of crosses over into the JSON world. That's not very fortunate, I think. So what I'm proposing on the next slide is that since everything we're doing is otherwise cozy, and that there is a cozy key format, there's even a cozy key set format. So there's even a way to encode a set of cozy keys. I think it would make sense for transparency services to have an interoperable way to expose their keys in that format. So instead of leaving it to the implementation to decide how it wants to expose the keys for the transparency service, I think we should have a thing where we say, no, this should be a cozy key set. They should be exposed at a fixed endpoint. That's part of the Scrappy API. And I think we'd have, so towards a cozier key discovery, I think that would get us, that would close the basic story for receipts. So if you can go to the last slide now. So we have a complete API for statement registration, which is very consistent and CBOR cozy all the way. Same thing for receipt issuance. We have synchronous and asynchronous issuance story now. And I think we're missing a little bit still is closing that key discovery story to have fully interoperable verification everywhere and enable async verification if people want to fetch keys ahead of time, store them and pin them somewhere. So if we switch to this cozy key set format for exposing those, I think that would complete this sort of pure cozy CBOR story end to end. And I think that's the last bit I would propose we do on Scrappy at this point. I think that concludes this section.
Okay, there's some interesting comments in the chat if you guys want to follow up. No questions? No one's in queue?
Thank you.
And this is the other slide deck. Do we have is Aoki?
Hi, can you hear me?
Yes.
Okay, so let's start.
Is this
Okay, good morning, good afternoon, Madrid, and good morning and evening. I will start, and next slide, please.
You want the next slide?
Next, please. Thank you. Quickly summarize individual use case extension ID. It is very simple, and there are two critical message. The first message is not meant to be ironic, and it started with the letter S. And SCITT working group, I know, and supply chain integrity and transparency and trust. But now, and especially the software supply chain integrity and transparency, trust. And so I want to adding the hardware and the computer architecture layer. The second one is, do you also consider protecting the component of an underlayer? And for example, the computer system, such as the hardware and something, the system software layer. And these measures will make the next SCITT and even more appealing, I think. And now let's break down the problem statement, and so that the working group will be able to start working on it or not. Next, please. For the first, the basically problem statement is how to comprehensively provide the supply chain security information for computing cost, resource, and software and hardware. Next, please. It is as you know, the SCITT architecture and Scrapify has grown into a specification that's excelling in providing the end-to-end the software supply chain security. So there are no issue and whatsoever with the software. Next, please. Looking beyond the IETF, the several interesting development has emerged. In particular, it appears that a statement format for SCITT is taking shape. Next, please. So what are challenging in the SCITT chapter 1 and other something, the interest specification? Focusing on computer system and the most essential strategy for supply chain security are, I think, the commander and the shield wall. For example, the PC and smartphone and IoT device are often structured in layers and from hardware to software. And the picture is like something, the computing and host, and hardware to the system software, and something the virtualization, and something the multiple and application and multiple the configuration. And they are the hardware and HBOM and software and SBOM and something the mapping. But however, those gaps will serve as a gateway to the future or something the threat. The next, please. Updating the problem statement. Isn't it necessary to combine the type of statement? Now let's take it on the step the future. Next, please. Even if there are multiple architecture, the computer system often has the following the configuration for each component. It would be a good idea to define the interface parts, such as the buckets relay, and it's like an extension, the adhesive schema, and something the hardware and software, or the multiple software and software, or something the multiple layer. The benefit will be engineers and for the procure and computers machine and system engineer who incident response to the critical incident, I think. And next, please. The updating the problem statement. Is it possible to map the merge statement supply chain security information. Let's say the answer and it's an answer to the use case for the Madrid meeting, the Yang, which has been success with the SBOM and vulnerable information, or the mood-based something schema, which is stronger in the hardware, will be the key. Next, please. So we have reached the final slide. Now what shall we do? I look forward to see the more potential and next and SCITT phase and together with all of you. Thank you.
I turned it off. Any questions? There's no one in queue. I actually have a quick question. So I'm going to actually join the queue, not as chair. So, kind of one of my, I guess fundamental thoughts, right, is understanding what it means to have secure hardware versus just making statements about hardware could be very different things than what we might want to assert about something about software security. And so do you envision that all of that work would happen in a rechartered scope for SCITT, or do you think that those are sufficiently different to require different kind of groups of people?
I think
And maybe you don't have an answer off the top of your head. That's okay. We can move forward.
thank you.
Oh, Hank, you're in Q2.
So I'm, as Yogesh is trying to find his hand, I think we initially envisioned the SCITT working group to recharter at some point to extend the scope. So I think also what we have to do a little bit of legwork to get the initial BOF proponents that were, I think, hoping to have the hardware immediately in scope, get them back on board. So I'm aware of a few stakeholders that personally I could ping, but I think it's a job for everybody who is interested in this work to get these in the room again. There's a meta concept here, I think, which is the semantics between statements. That's relatively independent of the application scope. That is a SCITT core functionality that we could extend. Yeah, where does semantics go? Is it in the header of the COSI? Is it actually a payload requirement? As we have been stated, opaque. We could introduce non-opaque statements that we give, like in between. Yeah, I can't say transparent statements anymore because this means something else. So it's a non-opaque statement. And so this is actually future work. So that would, I guess, be part of a rechartering from my point of view.
Yeah.
But I think IDs informing that chartering always help, and that would one of this would be this case one.
So, hello everyone. My name is Evangelos Haleplidis. Can you hear me? Yep. Okay, this is better. Yeah, fantastic. Great. Thank you. Okay, let me restart. My name is Evangelos Haleplidis. I'm from the Industrial System Institute in Greece, and I'm going to present you the work that we're doing in a EU project called Rescale. And actually, this may provide some insight on what could be some future work in the SCITT working group, or some kind of I don't know, input from us, or we can where we can use SCITT, where we can collaborate. At some point, I may disappoint Henk. I'll tell you when it is. All right. Just to give a brief, before we start and seeing how SCITT and Rescale can be aligned, just a brief. I need to provide you with a brief context of what the Rescale project is about. So probably most of the presentation is about Rescale. At the end, we're going to see how everything fits together, so that we all in the same have the same context. Just a brief view of what Rescale is. So actually, Rescale is an acronym. A revolutionized and enhanced supply chain automation with limited threats exposure. Right, IETF. We're using kind of the IETF kind of acronym styles. We're a 15 partners consortium for a 3-year project. We started on October 2013, so we're more than the halfway mark. These are the partners of the consortium. What's Rescale all about? So what we want to do is provide an end-to-end cybersecurity framework to secure supply chain and provide increased trust into the system. The first thing that we want to do is to develop and design a toolbox that users can use to assess, to make attack assessments on their products, both for hardware and software. And we have developed a number of innovative tools like side channel leakage assessments, microarchitectural attacks, fuzzy techniques, symbolic methods for dynamic and static and dynamic analysis. Actually, we have, based on the work done in Rescale, we already have discovered a number of unknown vulnerabilities which have been disclosed. So at the end, what we want to provide is what we call a trusted bomb. I'll come back to the actual definition of that, which want to provide this kind of trust and guarantees for the supply chain. And we also use blockchain in order to store and in order to actually have this kind of integrity mechanism. And of course, once a product is being used, we want to have a post-assessment monitoring mechanism that is going to provide, continuous assurance, continuous assurance, security assurance. So some more acronyms. Sorry about that. So the first is what we call a static supply chain guarantee, which is actually a report that comes when you run the static analysis tools that we provide, which is usually being provided by the owner of the asset, artifact, or the product, or what have you. The second is what we call the dynamic supply chain guarantee, DSCG for short, which also contains the result of the dynamic analysis tools, which is the way that we use it in Rescale is that the SSCG is done by the owner of the code or the product or whatever, and the DSCG is done by another entity, right? So you have more than one entities that are assessing the same product. Also, we have what we call bills of vulnerabilities, or BOV for short, which is a document that is continually updated from CV and CWE databases based on the SBOM that is included in the T-BOM. And of course, we have the aforementioned T-BOM, which is what we call the trusted T-BOM, which is actually the combination of all this kind of information, the SSCG, the SCG, and the BOV. So this is our structure for the T-BOM. Currently, is based on the Cyclone DX format. The SBOM, BOV, SSCG, and DSCG are as external references. The BOV has no hash because it's continuously being updated inside the T-bomb, I mean. So we have a number of all these results done by the static analysis tools are being inside these documents. And we have a number of other info points, trust assurance and testing proof that are still, we're still in development. We currently have a first implementation, an MVP or a minimum viable product ready. We have already provided some demos, but we're still working on some of the other issues, the other parts of the T-bomb. The SSG, DSG, and BOV are already part of the T-bomb. So this is the architecture that we have defined. We have at the top, we have what we call the assessment domain, and it's split in two parts, one for the static analysis module and the dynamic analysis module, where a user can download the tools and use them. We also have implemented this way so that you can put it in your CI/CD pipeline, where you can define it, download the tools, run the assessment, get everything ready, publish the results on our scale platform. At the middle, we have the management domain, where we have the dashboard where users can actually interact with the system. We have the state manager, the management module that handles the interconnections. And we have the trustor, which is actually the trust orchestrator that also creates the T-bomb, can validate the T-bombs already published, etc. At the bottom layer, we have what we call the security trust domain. We have the trust storage that, again, it's based on blockchain 2, and we're using Besu. And also inside here, we also have a certificate authority kind of thing. And we have the repositories and the security assurance that's actually monitoring used T-bombs that can provide notification if a new vulnerability is found on products that already exist in T-bombs. Okay, just be a little bit more patient. We're almost done with the rescale stuff. I just want to showcase you how the T-bomb, how the process is going on with how we generate it. We have defined three user types. We have the producer, which actually can use third-party libraries that may or may not contain a T-bomb, have a T-bomb already. Initially, of course, there's no T-bombs, but we expect that if this goes through and this kind of statements, T-bombs are being created, at some point we're going to have be able to incorporate them, right? So the T-bomb is going to contain information about vulnerabilities, so you know when you get and use your a third-party library, you know exactly what's happening inside there. So the producer is going to perform static analysis, static analysis on his own code. The consumer is someone that wants to use a software or a product that may or may not, that does not have an SSG but does not have a T-bomb. So he needs to go and do the dynamic analysis in order to generate a DSG and create a T-bomb. And the end user is simply a user that I just want to use the software that already has T-bomb. I'm done. I just want to validate it. So this is the process that we have envisioned and started in implementing. So a producer can get T-bombs for the third-party libraries that he wants to, or she wants to use. Then register that component through the dashboard, run static analysis, create the SSG. Then at some point, so the T-bomb is not being created here, right? At some point, someone wants to use it, or he delegates that to an external company or somewhere that, you know, please go ahead and assess my software because I want to have a T-bomb I want to share. A consumer is going to find that product, perform the dynamic analysis, generate the DSCG, and then the trustor is going to request the security assurance to have bills of vulnerabilities, and then the T-bomb is generated, and then the hash of it is stored in the blockchain. What I forgot to say is that in the T-bomb, we can also have not only S-bombs, but H-bombs as well. So that's one thing that was not mentioned in the previous presentation. All right, so where do we think SCITT falls into our architecture? So we think that currently the current version of SCITT falls here in the trust storage, how we store these statements, how we can validate these statements, and all these transparency services, etc. So everything falls under the trust storage. And here's where I will disappoint Hank, because I'm showing the architecture of the. I don't know if you wanted to break a streak, a streak of showing images of the architecture of SCITT. Sorry for that. Yeah, I know. Come on. Okay, so where does Rescale fall inside the SCITT architecture? So the SSEGs, DSEGs, T-bombs, etc., falls under statements. So these are statements that we do on the software or hardware or what have you of the supply chain. The user is the issuer that's going to sign all these statements, or we can have our modules sign that says, okay, the assessments have been done, and the SSEG is generated by the tool, right? And then we have these signed statements, which are the T-bomb. And then we're going to store this hash in the trust storage. Again, we use Besu for that. Generate these kinds of transaction ID, and then this is what we envision as a trusted statement, a transparent statement. Sorry, the T-bomb plus the transaction ID. So this is our view of how we fall into SCITT, right? Okay, so that's about it. Thanks for your attention. So where do we go from here? That's a question that I would like to answer. We would like to provide input into the SCITT working group. Are you interested in this kind of work that we do? Like, what kind of statements can be put inside? I don't know what kind of, as a use case, some part of the use case document. Yes, please.
Thank you for the work and connecting it to SCITT. Seems very relevant. I have a fundamental question. You talked about a lot of stuff about vulnerabilities. You talked about the SBOM. So you mentioned about the format used for SBOM, but one thing I wanted to know is what was are you following some industry standard on the vulnerability reporting in your system, as well as when you link these different type of statements in a T-bomb?
Yes.
Are you using any industry standard format for linking them, or is it your proprietary internal stuff
No.
used for that?
We are using Cyclone DX for all documents right
Okay.
now, right? And we use bomb links, if I remember correctly, to connect to the, to provide external references to these documents. So everything is, the way that it's written is pretty much standardized by Cyclone DX. We used Cyclone DX because it had better support for hardware for H-bombs, right? SPDX, if I remember correctly, has this kind of information, but I think we selected the Cyclone DX because I think it had better support at the time that we were looking at it. So yes, we're using that standard. And for writing the vulnerabilities right now for the static for the static reporting, we have the output is written in a specific format. It's called. I don't have it at the top.
Is it a VEX document?
It's Sarif. I think Sarif. It's Sarif format for the output of the static analysis tools, and we store it inside Cyclone DX has kind of this, information that you can put. And what we did for initially, in order to attach this kind of output, it's in a string, and we put it as a base 64 encoding, right? And we put it inside there.
Yeah, I have a follow-up question. You talked about mapping it to SCITT.
Yes.
You talked about the different statements, putting it into the SCITT transparency service. Is there a verifier story as well in your system?
Yes, of course. Yes, we have the trustor and the validator here. Probably I should have put a little bit of SCITT there. Sorry about that.
Yeah. Okay.
Yeah.
By the way, I forgot to introduce myself. It's Yogesh Deshpande from ARM. I'm one of the authors of the SCITT.
Okay. Thank you. Thank you for that. We also have, if anyone is interested, I can showcase the dashboard, the T-bomb structures and everything. Find me. I can give you a demo. Provide you some info on the, this is the structure of the S-bomb. We have already some initial test cases, run a couple of things, generated these documents, so I can showcase them to you. Yes, Hank.
Yeah, hi, this is Hank. I heard use case document. Yeah, I think that is never wrong. So if you contribute to that, it can't start as early as possible. So now is the time. So that's a good plan. If you go back one slide, I think, where's the mapping, the colorful mapping overlay, exactly. So is the receipt, so first of all, when you get the receipt back, you have to decide for one verifiable data structure. You're using some blockchain right now
Yes.
that might retain the same thing. Doesn't matter, as long as it's a verifiable data structure,
Yes.
you're golden. Is the receipt itself the transaction ID? Or do you have certain requirements on transaction IDs that would have to go into the receipt? You need to profile the receipt. This is unclear from here.
Once the T-bomb is generated, we don't add anything more inside, right? Because the hash of the T-bomb is going to be stored, so you don't want to change that. So the ID is a way to simply, find it again inside the blockchain.
Makes sense. We had discussions about statement IDs in general, and we decided to not put into the core because there are certain subtleties to IDs when you have multiple transparency services and get multiple receipts. So you have to kind of be unambiguous there to enable the unequivocation stuff. I think that's something we have to talk about just as of ongoing work, but it could be a hint there in your use case that how and why you want to identify something and how to trace it and combine it in the end.
Okay, that's a good comment. Thank you. So, anyone else? We have a couple of videos that can showcase the process, and actually these demos are by our pilot partners that they have incorporated the whole thing into their CI/CD system. So they just code everything, have everything, log in directly into the dashboard, download the tools, run the tools, generate them. We also have this kind of dry runs where you run the tests just to make sure that you don't have vulnerabilities, fix them, and then you get once you're done, then you can run it for the permanent result. We also envisioned for the T-bomb to have this kind of tiered access, because when you develop these vulnerabilities, you don't want everybody to see them. You may want to showcase that I found vulnerabilities, but I don't tell you what they are. If I really want to use the software, then I may sign an NDA or something that I can start seeing what these vulnerabilities are, and then I want to incorporate that into my solution. This kind of stuff. These are things that we have been discussing inside the project. I'm happy to provide any more information. Find me later on. I'll be here. Thank you as well.
All right, we will have a few minutes for VCons. And I will just say from a chair's desk, I just want to thank Emery for being a document shepherd. So thank you. All right, who's doing the VCons? All right, come on up and tell us who you are. You don't have any slides or anything that. Yeah. Okay. That's good because that would hurt.
Should I jump in the line or just go?
Just come on up.
I feel young. Hi, my name is Thomas Howe, and I'm working with the VCon group. I just want to just have a quick note here. Steve Lasker, Diana James, and I have been working on 2 documents that interact between SCITT and VCons that we are currently considering in the VCon working group for adoption. The first document that we're working on is called the VCon consent attachment, and that is an addition to the VCon to allow us to put the consent that was gained with the recordings that are inside the VCon. And in that attachment, we reference the SCITT ledger that contains the information around the life cycle and the consent for that particular VCon. The second document we have is called VCon life cycle, and that determines all of the verbs that happen between VCons and the SCITT chain to indicate when VCons are created, modified, shared. In addition, when consent is gained or withdrawn. And we're using the SCITT ledger to enable systems across security boundaries to be able to enforce the personal data rights of the people who were recorded. So these are the VCon working group meeting is Wednesday. I think it's at 1. And I'd like you all to have a chance to come visit us if you'd like. And I wanted to just make a personal thank you to John Geeter and Steve Lasker and Diana James for doing this work with me. Thank you.
Thanks. That brings us to end of the agenda information, which I think we're pretty much closed out. If anybody wants to join the queue, John, any closing remarks?
No, we should yield to Henk.
Yeah, just a final comment from me. This is Henk. Yeah, this looks so. Application of it is great because then we can increase interop testing, and I think that is the best thing to do here because this is the whole point. So thank you for bringing this up. We'll try to be at your working group and meeting, and yeah, thank you for the participation across the boundaries of this working group. It's really great. There will be others, and yeah, let's go to the interop for the next meeting.
I'll just make a note, kind of chair procedural note, to move things from proposed standard to standard is generally 3 interoperable separate implementations. So yeah, you're almost there. All right, I'll give everybody back.
Fantastic.
Go ahead, John. Is that it? Well, there you go. Okay. I'll give everybody back a few minutes if there's no other business. And Michael, love to have the conversation about 2 versus 3, but sure. Yes, please. That's it. Thanks, everybody.